All right, so this is called the graph of y equals tangent of x. And let's try it. Describe how to determine the key characteristics of the graph of the tangent function and graph it. Like I said, a lot of words to write today. Sorry. All right, so the tangent function has properties that are different from sinusoidal functions. And remember, sinusoidal functions are sine and cosine. Its graphs differ significantly from those of sine and cosine. All right, so now let's talk about the properties of the tangent function. Properties of the tangent function include the following. All right, so what is the period for sine and cosine? It's pi. Well, guess what? The period for excuse me. The period for tangent is just pi. So that's one thing that's different. The period is pi. The remainder of the graph consists of repetitions of the graph at intervals of pi. Just like sine and cosine, we usually graph over one period unless they specify otherwise, and then we know it just continues on onto x is positive infinity and x is negative infinity, just the same graph repeating itself over and over, right? Well, same with tangent, but the period is pi, and then the repetition repeats itself at every interval of pi. The tangent function is an odd function not because it's weird. The tangent function is an odd function. The graph is symmetric with respect to the origin. The tangent function is undefined the graph of y equals tangent of x has a vertical asymptote at pi halves. And remember, an asymptote is like kind of like an indivisible line on your graph that your graph approaches, but it does not intersect. One more thing to write. We obtain a graph of y equals tangent of x using some key points on the graph and origin symmetry. All right, you guys all right that? Another second or two. We good? All right. So the good news is when we're graphing tangent, we can actually use our calculators to find tangent, which you can with sine, cosine, all that stuff too. However, with tangent, I'm actually allowing you to use your calculators. We're going to find key points, and they're going to be rounded a lot of times, and so I don't need exact answers. And so you're going to be able to use your calculator, and I'll have to show you how to do that. Now on the calculator, when we've been finding sine and cosine, are we talking about radians or degrees? What do we deal with in trig? Radians. So the crazy thing is when you use your calculator, you have to make sure it's in radians. Generally, it's in degrees, okay? So those calculators that I let you borrow, and remove that, can you see? Oh, there you go. See how it says RAD above the zero? That's because I just converted it to radians, okay? If yours says DEG, yours is in degrees. So to convert it back and forth on these two activities, if you're using a graphing calculator, it's different how you do it. So see the green second button, and this is DRG, right? So if I want to convert from one to the other, just hit the second DRG. Now that says, mine says GRAD, second again, DEG, that's generally what we do math on, degrees. Regular old math is degrees. If we are doing trig, we want that to say our AD, so I'll hit the second degree again, and to switch it back to radians. But if you'll do me a favor, when you leave this class, turn it back into degrees, because my Algebra 2 classes, we don't do trig for till the end of the year, and they're not going to realize that this is not on the setting that it's not supposed to be on, and they're going to get a bunch of wrong answers. So I'll try to remember to remind us at the end of the day, but unless you're using your own calculator, please convert it back to degrees, okay? And I'll try my best to remember that. So I'd have to look at your calculator. Yeah, bring it up here. And they're all different. I mean, I know how to do mine, but been so long since I've changed it online. I can't. This is similar to what I have, but I can't remember. So use one of mine for now, and then when I'm not recording anymore, I'll figure it out for you. I mean, it's real easy to do. You just got to remember which actual setting that you go under. Okay. All right. You're welcome. All right. So next page. First example. We are going to, well, let's see, group period. We're going to graph y equals tangent of x. And this is the most basic tangent graph we can get. It's a parent function. Okay, so I just told you that the period is from a length of pi, right? Period is at the length of pi, so it's 1 pi long. But at pi halves, there's an asymptote. Okay, so let's see, we have a graph here. So let's do the y-axis. And at pi halves, there is an asymptote. Well, there's also an asymptote at negative pi over 2. Well, for negative pi halves or positive pi halves, would that be one full inverse? Would that be a length of pi? Yeah, so that's one cycle, right? Because at the asymptote, your graph is not going to touch across the asymptotes, all right? So we're just going to pick some points to try to figure out what this graph looks like. And we don't have to do this every time, okay? I'm just going to show you on this one what to do, or how I'm coming up with this. So, all right, well, let's find the tangent at 0. I'm just going to make a little table of values on the side. We're going to use our calculator. So really, the calculator's doing all the math. We're just going to find some points. I'm going to go from 0 to pi halves to start with. So y equals the tangent of x. So let's see, when x is 0. So in my calculator, well, first of all, don't we know that tangent is y divided by x, right? So we don't even need our calculator for that, because what is the cosine at 0? What's the sine at 0? So what's 0 divided by 1? 0. So we know that the tangent of 0 should give us 0. In my calculator, to find the tangent of 0 using the TI-30XA, I would put 0 in first, then hit tangent equals, and we get 0. Again, oh, it's in degrees. 0 is not going to make a difference. 0 tangent is 0. Radians or degrees is still 0. All right, so I'm going to plot a point at 0, 0. Let me just find some other number between 0 and pi halves. What number is halfway between 0 and pi halves? Pi fourths. All right, well, let's figure out when your x is pi fourths, what's the tangent? So in your calculator, this calculator has a pi button. So pi fourths, so I do pi divided by 4, right? Pi, 3.14 approximately, divided by 4, and then push equals. That's not the tangent. I just did what pi divided by 4 is. Then I have to hit the tangent button, and I get 1. So at pi fourths, y equals the tangent of pi fourths, I get 1. All right, well, let's find some other points because I know it's not going to be a straight line. What point would be halfway between 0 and pi fourths? So what's half of pi fourths? Pi eighths. So let's figure that out. When x is pi eighths. So y equals the tangent of pi eighths. So in my calculator, pi divided by 8 equals, and then hit tangent, and approximately 0.4. So at pi eighths, I'm going to put a point at 0.4. All right, well, let's find x value between pi fourths and pi halves. Halfway in between that. So that would be 1/4 of pi halves. No, sorry, 3/4 of pi halves. So wouldn't that be 3 pi over 8, right? And this is pi halves, 3/4 of the way through. 3/4 times 1/2 is 3/8. So 3 pi over 8. All right, well, that would be 3 pi. No, 3 times 3 times pi is equal to 9.4 something. Divide that by 8, and you get 1.17. We got to take the tangent of that. I did something wrong. Oh, so it keeps flipping back. So I got to do radians every time. Is that what's happening? I'm just using my graphing calculator. Usually every year I let all my students use my graphing calculators when we do trig, but because of COVID, I can't do that. So we got to use these calculators for trig, which is not fun. This is why you're supposed to have a graphing calculator for pre-calc. Yeah. Are you in radians? So your calculator is a little different than this. You might have to enter it differently. These calculators, these TI-38s are very backwards. So try entering yours a different way. Try putting tangent first maybe, and then put in the number, and see if you get the same thing I do. All right, so thank you. That was in degrees. Let me try again. So 3 times pi equals, divided by 8 equals, and then we're going to take the tangent of that at 2.4. So y equals the tangent of 3/8 pi was approximately 2.4. So 2.4. So it looks like the right side is going to go up and hug that asymptote. But remember, you have an asymptote at pi halves, so the graph is going to hug the asymptote. It's not going to cross the asymptote. Well, okay, we've only graphed half of the period. Let's see what the other half looks like. Okay, so I'll use these same numbers, but I'm just going to go negative. So halfway through would be negative pi fourths. We've got negative pi eighths, negative pi fourths, and negative 3 pi over 8. So let me show you something. At pi halves, if you were like, well, where do I plot a point at pi halves? Well, I'm in radians. So if I do pi divided by 2 equals, and the tangent of that, it says error. I didn't think it says error because it's undefined at pi halves. There's an asymptote there. There's no point on this graph that will have an x value of pi halves. What do you think it's going to say if I do negative pi halves? Find the tangent. So negative pi divided by 2 equals tangent of error. So when that happens, if you forget about the asymptotes, that's going to be a clue. Like, oh, yes, it's undefined at that number because there's an asymptote there. All right. All right, so let's do negative pi 8. So on these calculators, you do pi and then the negative sign divided by 8 equals, and then hit tangent, so negative 0.4. All right, now I'll do negative pi fourths. So y equals the tangent of negative pi over 4. So my calculator, negative pi divided by 4, negative pi divided by 4, and then I push equals. If you don't push equals, it's going to take the tangent of the last number that you had, and then push tangent. And I get, what do y'all get? Negative 1. Okay, okay. Now let's find the tangent of negative 3 pi over 8. So y equals the tangent of negative 3 pi divided by 8. Very particular how you have to enter it. So 3 times pi negative divided by 8 equal sign, and then a tangent, and I get what y'all get. Negative 2.4 approximately. Exactly. So 1, 2, and I already know through the negative pi halves it's going to be, there's an error there because it's an asymptote. So you know how sine and cosine? My domain for sine and cosine is what? negative infinity, positive infinity. Is my domain for tangent going to be negative infinity, positive infinity? Well, yeah, technically it is, because this pattern is going to repeat itself over and over and over on the left side and on the right side. So it really will, okay? But you see, obviously it looks different than sine and cosine. And sine and cosine does not have asymptotes like this does. So let me just write a few things. I'm just going to point out at x equals pi halves and x equals negative pi halves, y is undefined because those are asymptotes. Also, notice as x increases from 0 to pi halves, y increases slowly, then more rapidly. Oh, and I said that your domain is all real numbers. Should I have said that? Is your domain really all real numbers? Can your domain contain an x value of pi halves in this graph? Can it contain a y value of negative pi halves? No. So this repeats itself over and over and over. So your domain is all real numbers except all intervals of pi halves. Okay, which we're going to write all that down on the next example. I just wanted to point that out because that did say your domain would be all real numbers, and it's not exactly true. Now, what do you think your range is going to be? Your range is your y values, right? Your range will be all real numbers always for tangent. I don't think we really talk about those with tangent. No, I don't want to answer that question 100%, that we don't have stretches and shrinks, but not that I have in my notes anywhere. All right. Next page, all words. I know you'll love that. All right, because the period of the tangent function is pi, oh, and if you want to clean your binders out, I would, what we're working on now, since we started trig, like don't leave that in your first semester binder because we haven't tested out on it yet. So if you're going to get a separate binder for second semester, bring everything since we started trig, unit circle, all that stuff. Make sure it's in the same binder because we haven't tested on that yet. If you don't want to, if your binder holds everything, cool, mine doesn't. So I probably will just get a new binder so that my first, everything from the first can just stay in its own little binder, but I'm about to run out of room. All right, because the period of the tangent function is pi, the graph below shows one complete period of y equals tangent of x. We obtain a complete graph by repeating to the left and right over intervals of pi. the resulting graph and its main characteristics are shown below. All right, the characteristics. We already know the period for tangent is pi. The domain, all real numbers, except odd multiples of pi halves. The range, all real numbers. Vertical asymptotes, at odd multiples of pi halves. And x-intercept occurs midway between each pair of consecutive asymptotes. And one more thing, tangent functions are odd with origin symmetry. So we're going to graph several intervals of y equals the tangent of x on the same graph, just so you can see, like, what am I talking about when I say except odd multiples of pi, or the vertical asymptotes are odd multiples of pi, and the x-intercept occurs midway between each pair of consecutive asymptotes. Like, what? So on the same piece of paper at the bottom, I'm going to draw an x-axis all the way across. And I'm going to put a y-axis in the middle. And we know that first interval of y equals tangent of x, there's a negative pi halves on the left side and a pi halves on the right side, right? So let me figure out what those intervals consist of. Well, each interval, or each cycle period, is pi, all right? But we have, so from negative pi halves, that interval is at pi. And we know at each odd multiple of pi halves, there's going to be an asymptote. So I'm just going to keep increasing by pi halves, by pi halves, by pi halves, by pi halves, to find some more, okay? So what is pi halves plus pi halves? Pi. What's 3/2 pi plus pi half? So 3/2 plus 1/2 would be 2 pi. Let's see one more. What's 2 pi plus 1/2 of pi? 5/2 pi. So we'll put these same numbers over on the other side. So we have negative pi halves, negative pi, negative 3/2 pi, negative 2 pi, and negative 5/2 pi. We know there's an asymptote at negative pi halves and at pi halves. Vertical asymptotes are at odd multiples, okay? So basically every other one. So am I going to put asymptote at pi? No. At 3/2 pi? Yes. Is there going to be asymptote at 2 pi? No. How about 5/2 pi? Yes. Same thing on the other side. We'll have an asymptote at negative 3/2 pi and at negative 5/2 pi. And of course that can go on and on, so positive infinity on the x-axis, sorry, and negative infinity on the x-axis. So your graph crosses the x-axis midway between each consecutive pair of asymptotes, right? So we've got two asymptotes here. Where the graph's going to cross in the middle. The right side is going to increase slowly and then go up above the asymptote. The left side will decrease slowly and then rapidly as it approaches the asymptote. You need a different color because that's not very bright. So with tangent, we can do the table of values. Or you know how with sine and cosine, I'm like, I know you know what the graph looks like, but you have to show me the table of values. Well, that's because we use the sine and cosine evaluating those functions a whole lot. Tangent, cosecant, and all those not so much. So when we graph these, you don't really have to show me the table of values. You just have to have everything labeled and set up and done the right way. So between pi halves and 3/2 pi, where is my graph going to cross the x-axis? At pi. So the right side will increase slowly and then more rapidly as it approaches the asymptote. Going to the left, it will decrease slowly and then more rapidly as approaching the asymptote. Same thing. In the next two asymptotes, it'll intersect the x-axis right in the middle. And then I'm going to go to the left side as well. So of course there's going to be variations for tangent graphs. But we will learn those tomorrow because we have the next page of notes is all words and it is a few minutes before lunch. And so I don't want to start that and then another video right in the middle. And so tomorrow we will pick up where we left off. Make sure everybody turned in graphs of sine and cosine. That last assignment, I think I gave it last Wednesday. And I told you it would be on quarter 3, first grade quarter 3, so make sure everybody has that submitted. And then we are done for the day. So at home, once you have this copy, go ahead and log off. Then I'll know everybody's finished and I will log on in the video.